Hi everyone, welcome to Old School Chemistry. We are going to do an acid-base reaction. This comes from the Jee Main Exam on August 31st, 2021, 3 o'clock to 6 o'clock exam. We're going to do question number 3. Let's read it together. It says, 50 mils of a 1 molar HCl is mixed with 30 mils of a 1 molar sodium hydroxide. What is the pH times 10 to the 4? So a couple of background things I want to go over. First of all, this is a neutralization reaction. You've got a strong acid and a strong base. And whenever you add a strong and a strong, you always get this reaction right here, a neutralization reaction. Little reminder, on the strong acid, it always 100% ionizes, which means when we dissolve hydrochloric acid into water, it's going to produce H plus and a Cl minus, that hydrogen ion on the chloride ion. Likewise, sodium hydroxide being a strong bases always 100% dissociate when you dissolve them in water. So this is going to completely dissociate and break into your sodium ion and the hydroxide ion. Now a reminder on the chloride and the sodium ions, those are neutral spectator ions. I will put a link up above if you need help identifying those spectator ions and how to write a net ionic equation. Those spectator ions, they are not going to impact the pH. They don't react. They just observe the reaction and float in the water. They don't do anything. So what's left over, the active species, are going to be the hydrogen ion and the hydroxide ion, and that's going to produce our H2O. Now, to figure out the pH, when you have acid-base reactions, there are 3 steps, and I'll also put a link for these 3 steps. Number 1, you always do final initial moles, okay? Number 2, you're going to account for the dilution that you're pouring and adding volumes together. And then number 3, you determine the pH. You figure out that pH. So here we are on step 1. I had to find the initial moles. So I did that calculation right over here for you. Remember our information in the stem, in the question. We have 1 molar HCl, so that means 1 mole per 1 liter. And we know that 1 mole of HCl is going to ionize, produce 1 mole of that hydrogen ion. We had 50 mils, I just divided that by 1,000 and got 0.050 liters. So notice what cancels out, mole of HCl and liter, and we're left with 0.05 moles of H plus. So in this solution, we're going to have 0.05 moles of H plus floating, and that's what I put here. That's the initial amount that we begin with. Let's look at our sodium hydroxide, also 1 molar. So 1 mole of sodium hydroxide per 1 liter. 1 mole of sodium hydroxide is going to dissociate and produce 1 mole of hydroxide. Multiply that by our 30 mils. I just divided that by 1,000, got 0.03 liters. Notice mole of sodium hydroxide cancels, liter cancels, and you have 0.03 moles of hydroxide. And so I put that, that's what we begin with here. Now water is a liquid, so it's not going to be a part of our initial final moles. It's only the aqueous species that we look at initial final moles. Okay, now this is a 1-to-1 molar ratio. For every 1 hydrogen is going to react with 1 hydroxide. If I have 0.03 here, all we have to do, the quick, fast, dirty way to do this is subtract. This will be our limiting reactant. The hydroxide is going to be completely consumed. When I subtract 0.03, 0.05, the final moles left over are going to be 0.02 moles of hydrogen. So we did our initial and final. What you begin with initially, once the acid and base react, what you're left with. Now this is what's going to impact the pH. So we can now go to step 2. For step 2, we have to account for the fact that we poured 2 solutions together, we changed the volume, which in essence dilutes the entire substance. Remember, we had 50 mils and 30 mils. 50 mils, and I poured it into this 30 mils. So my total new volume is just 50 plus 30, 80 mils. Let's convert that to liters, divide it by 1,000, and you get 0.08 liters. So now we can find the new molarity. What's the new concentration of the hydrogen that's left in this solution? I take my 0.02 moles of the hydrogen ion, divide it by the 0.08 liters, and there you have it, 0.25 molarity. Now why we have to bring this back to molarity, why I don't just leave the moles, is because we're going to calculate pH. And all of our calculations with pH involve molarity, moles per liter, concentration. So now we can go to step 3. Now that I have molarity, we can find the pH. Now, interesting point. If we had done this reaction and ended with a weak acid or weak base, in order to find pH, we would have to do an ice table. However, because our species that's left over is hydrogen, and hydrogen determines pH, we can go right to pH equals the negative log of the hydrogen concentration. So I plug it in. pH is going to be the negative log of 0.25, my molarity, which gives us 0.6021. And then the question asked, what's the pH times 10 to the 4? I just moved that decimal 1, 2, 3, 4 places, and there you have it, 6,021 times 10 to the 4. And that's your answer. Good work. I'm so proud of you, and good luck on your test. Blessings to you. Thank you.